Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. I hope you always in good condition. Stay healthy and stay happy. Okay, today we will learn about the composite integral, also known as the multiple quadrature. So there are three types of the composite integral that we want to learn. First is the trapezoid rule, second is the midpoint rule, and the last is Simpson's rule. So let's to learn about the trapezoid rule. You look in the screen. This is the summarize of this chapter. So the composite rule, we have the composite trapezoid rule. We have TF as a code. TF equal h/2 times the function of A plus 2 sigma G equal 1 to N, the function of xg plus the function of B. And the integer N, this is the N, can be either odd or even. And then to look for the estimate error, we can B minus A times h squared over minus 12 times second derivative of the epsilon, where the epsilon is the element of A and B. Okay, and then the second, there is midpoint rule. The composite midpoint rule, we have the code MF. We have MF equal h times sigma G equal 1 to N, the function of x0 plus J minus 1 over 2 times h. And remember, the integer N in this, N can be either odd or even. And we can also look the estimate error with B minus A times h squared over 24 times second derivative of the epsilon, where the epsilon is the element A and B. And last, we will learn about the composite Simpson's rule. We have the code SF with SF equal h over 3 times the function of A plus the function of B plus 4 sigma G equal 1 until N over 2, the function of x to G minus 1 plus 2 sigma G equal 1 to N over 2, the function of x to G. And the integer N in here and also in here must be even. So we cannot use the odd. It must be even. We have to remember for the Simpson's rule is different like the midpoint rule and also the trapezoid rule. So we can also estimate the error. B minus A times h to the power 4 over 1 minus 180 times the fourth derivative of the epsilon, where the epsilon is the element A and B. So we have the exercise in here. Approximate integral 0 to 2 1 over 1 plus x using h equal 1 over 2. First, use the composite midpoint rule. Second, use the trapezoid rule. And last, use the composite Simpson rule. And calculate estimate error for each method. First of all, we have to look for the exact value of the integral 0 to 2, 1 over 1 plus x is almost 1.099. For midpoint rule, we have from the information given a equal 0, b equal 2, and h equal 1.5 or 1 over 2. First of all, we have to look the value of n. And how we can look for n, we have n equal b minus 1 over h equal 2 minus 0 over 1 over 2 or 1 over 2 is equal 4. Kita bisa mencari nilai xj. We can look the value of xj. So we can, if j equals 0, we get xj is 0, and xj, the function of xj is 1. It gets from 1 plus 0 is 1. From then we get j is 1. And then we get j is 1, xj is 1 over 2, and also the function of xj is 2 over 3. And you can also look this, you can search this table until n is 4 by yourself. Second, look for j. We know that j is sigma j equal 1 to n. The function of x0 plus j minus 1 over 2 times h. We understood that in the sigma, j is 1, 2 until n. Because in the first step, we know that n equal 4, implies that j, the value of j is 1, 2, 3, and 4. You can look this table. This is to help you to understand how to look the function of the value of the function of x0 plus j minus 1 over 2 times h. So we can look for the MF. So the MF is h times g, times sigma g equal 1 and to n, the function of x0 plus g minus 1 over 2h. We get the h is 1 over 2 and times j is equal 1 to 4, and the function of x to g minus I'm so sorry, it should be the function of x0 plus j minus 1 over 2h. I'm sorry, because this is the table in here. Yeah, it should be here. I'm so sorry for my typo. And next, we can calculate the h is 1 over 2 times 85 over 39. So the MF, we get the result as 85 over 70, 80, with the MF is 1.089. So we can calculate the error, the exact absolute error equal 1.099 minus 1.089 is equal 0.01. Jadi ini dapat dari yang the exact value tadi ya, nilai exact. Yang ini yang tadi kita dapat nilai MF-nya. Jadi kita mau cari estimasi errornya lagi. Ini udah berbeda dari yang nilai absolute exact-nya. We understood that the function of x equal 1 over 1 plus x. The first derivative is the function f, the function x equal minus 1 over 1 plus x square, and the second derivative of the function x equal 2 over 1 plus x to the power 3. So the estimate absolute error is with the formula in the first page that I showed you before. Estimate error equal the absolute b minus a times h squared over 24 times the second derivative of the epsilon, where the epsilon is the element of 2 and 0 and 2. So we get the we can input the value of b, a, and h, and also the epsilons. B is 2 minus 0 times 1 over 2 square over 24 times the second derivative of the epsilons. So we get 1 over 48 times 2 over 1 plus the epsilon of, I'm sorry, this is, it should be, oh yeah, right. 1 plus the epsilon to the power 3, with the epsilon is the element of 2 and 0 and 2. So we look for the value of the epsilons. Di sini kita akan cari nilai the epsilon. Nilai epsilon itu kita dapat 0. Kenapa 0? Kita lihat dari grafik ini, karena saat 0 nilainya tuh tinggi, yaitu 2, sedangkan di saat 2 nilainya tuh rendah. Karena itu kita ngambil epsilonnya itu 0. So we get 1 over 24 is almost 0.0412. Okay. I think that's all for the information about the midpoint rule. The Annisa Aolia will present to you about how to solve this problem with the Simpson's rule and the trapezoid rule. Thank you very much for your attention.
Okay, thank you, Anggun. Next, we will calculate approximate integral 0 to 2, 1 over 1 plus x using h is equal to a half. Use the composite trapezoidal rule and use the composite Simpson rule. Remember, the exact value integral 0 to 2, 1 over 1 plus x is equal to 1.099. And first, we use the composite trapezoidal rule. Okay, in here, we have a is equal to 0, b is equal to 2, h is equal to a half. So we need to look for n. N is equal to b minus a over h is equal to 2 minus 0 over a half. So we have n is equal to 4. And then in this table, we have x0 is equal to 0, x1 is equal to a half, x2 is equal to 1, x3 is equal to 3 over 2, and x4 is equal to 2. This is plus a half, plus a half, plus a half, and plus a half. So we get fx0 is equal to 1, fx1 is equal to 2 over 3, fx2 is equal to a half, fx3 is equal to 2 over 5, fx4 is equal to 1 over 3. Next, we will calculate DNF is equal to h over 2 times fa plus 2 sigma fxg plus fb for g is equal to 1 until n. So we enter the value of this function into this formula. So we get like this. A half over 2 times f0 plus 2 times f a half plus f1 plus f3 over 2 and plus f2. So we get DNF is equal to 1.117. And then we will calculate the error. Exact absolute error is mutlak exact value minus approximate DNF. Like this. And we get mutlak 1.099 minus 1.117. So we get exact absolute error is 0.018. And then we understood fx is equal to 1 over 1 plus x. So we got one derivative fx is equal to minus 1 over 1 plus x squared. So we get the second derivative fx is equal to 2 over 1 plus x to the power of 3. So the estimate absolute error is equal to mutlak minus b minus a times h squared over 12 times f times second derivative epsilon, where epsilon element 0 to 2 until 2, and then we get 1 over 12. So 1 over 12 is equivalent with 0.083. This is must be bigger than this absolute error, right? Next, Simpson's rule. We have a is equal to 0, b is equal to 2, h is equal to a half. So we need to look for n is equal to b minus a over h is equal to 2 minus 0 over a half. So we need n is equal to 4. In this table, it is same with trapezoidal rule. x0 is equal to 0, x1 is equal to a half, and so on. You can try this, and then we look for SF. SF is equal to h over 3 sigma fx2g minus 2 plus 4 times 5x2g minus 1 plus fx2g for g is equal to 1 until n over 2. And we enter the value for this function for the formula into the formula. So we have a half over 3 sigma fx to g minus 2 plus 4 times fx to g minus 1 plus fx to g for g is equal to 1 until 2, and then we got 1 over 6 times fx0 plus 4fx1 plus fx2 plus fx2 plus fxx3 plus fx4. So we got 1.1, right? And then we calculate the error. Exact absolute error is exact value minus mutlak exact value minus approximate SF. So we got mutlak 1.099 minus 1.111 is equal to 0.00 and 1. So we understood fx is equal to 1 over 1 plus x. And then we look for derivative fx. So we got for derivative fx is equal to 24 over 1 plus x to the power of 5. So the estimate absolute error, we use this formula is equal to mutlak minus b minus a negative b minus a times h to the power of 4 over 180 times for derivative epsilon, where epsilon eliminated 0 until 2. We entered the value and then we got 1 over 60. 1 over 60 is equivalent with 0.01667. This is much bigger than exact absolute error, like this. This is much bigger. Okay, and next, the conclusion. We have midpoint rule. Approximate is 1.089 and the error the error is 0.0412 and trapezoidal rule approximate is 1.117 and the error 0.083 and Simpson rule approximate is 1.111 in the error 0.01667. So Simpson rule is the most accurate because in this error is close to 0. Okay, that is all for me. And I hope what I have shared will be beneficial for us. And thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.